This question number one. Find the temperature at which the slope of Z versus P curve has the maximum value for CO2 gas. Try to solve this problem. Try to think what kind of questions JEE has asked in the real gases, what kind of questions they can ask, and what could be the variation, what they have not asked, they can ask, because real gases is a very interesting topic as far as engineering is concerned. As far as gaseous state is concerned, the very important topic is real gas. So let us discuss about this thing. You have any approach? Anyone?
Sir, I got temperature to be as low as possible
You got temperature as low as possible. Okay. So what was your approach with Prakash?
using van der Waals equation. I wrote V in terms of T and T, then I written Z and differentiated it with respect to P, keeping T constant.
Keeping T constant. Yes, that could be the approach. That could be the approach. But why we are not getting the answer? That I have to see. So without getting answer, have you got some expressions like T is equals to 2A upon RB, something like this?
No, sir, I got dz by dp in terms of 1 by t square and 1 by t.
Let me try. Let me try. If I have any done mistake, please tell me. And I'll also see very interesting thing you're telling me. Or if there is any mistake in your approach, you can also tell me. So basically, van der Waals equation is Z is equals to 1 plus one form you know, that is B minus A by RT into 1 by V plus 1 upon V square. And this is of course B square. This one form we know. And B cube upon V cube. You're already familiar with. I don't need not discuss this anymore. Okay. Is that all right? Now in this, since we are requiring Z versus P graph. So naturally, this is for the ideal gas. For the real gases, it is like this. Most of the gases like this at any given temperature, and you increase the temperature, that becomes like this. If you still increase it further, it becomes like this. And if you still increase it any further, then there will be a slope. And we are asking, what is this slope? What is this maximum slope? And especially when limit T tends to 0. So as we know, as we go P tends to 0, so P tends to 0, gas should behave like this. Z should tend towards 1. Most of the gases, Z should tend towards 1. All right, Z will be tending towards 1. But the slope dz by dp will not be tending towards 1. If dz by dp is tending towards 1, if dz by dp is tending towards 1, we call it what? You remember? We call it Boyle's temperature. That we are familiar with. So how to attack this problem? We require what? Z versus P graph. Now this is something, yeah.
Can we call the Boyle's temperature as which the gas starts to liquefy? This starts to liquefy?
No, Boyle's temperature, no. Gas starts to liquefy nearly at critical temperature, and critical temperature Tc is equals to 8A upon 27 RB according to Mr. van der Waals. It's not according to the real thing, but according to van der Waals, it is 8A upon 27 RB. So you can see that it is equal to what? A by RB, you take a factor. That's a very important factor in real gases. And 8 by 27 is nearly 1 by 3. So that means the critical temperature is the lowest temperature kind of a thing. There are 3 kind of temperatures. TC,
Highest temperature, sir,
TC, TB, and T inversion. Have you heard of it? So TC is nearly 1 by 3rd of R upon AB, A upon RB, and TB is nearly what? 2A upon RB. So you see what is the difference? And T inversion is equals to, sorry, I'm so sorry, A upon RB. This is Boyle's temperature, and T inversion is equals to 2A upon RB. Is that clear to everyone? I hope I have not done any mistake here. Yeah. So you see, if the critical temperature is 100, then TB should be what? Guess, any guess? It should be 300 Kelvin. And this should be what? 600 Kelvin. So that is the difference between these three temperatures. Keep it in mind. So gas started liquefying near this. This is the liquefaction point. But this is the point where it will start behaving ideally. And this is the temperature below which we know this, below which gas what? Cools upon expansion. These are the three very important temperatures. Understand? Please give affirmative. Do you understand? Yes. Let's move ahead. So as usual. So that is Boyle's temperature. So the gas will start behaving like, liquefaction will only take place below critical temperature. And all this graph has been plotted at T greater than Tc. And these temperatures are T is greater than Tc. Understood? So let us move ahead. चलो आगे देखते हैं. तो Z वर्सेस P कैसे निकालोगे? Z वर्सेस P निकालने का सिंपल मेथड. First, let's talk about the simple method. I'm just discussing the theory of this problem, then I will come on this problem. Problem is very simple, but I am going to discuss the theory of this problem first. Simple method is P is equals to, Z is equals to 1 plus 1 by V A minus B by RT. Oh no. B minus A by RT plus B square upon V square plus so on and so forth. So we can also think about it in terms of limit pressure tends to 0, gas behaves ideally. So that is a very crude approach. This is very crude approach, but at least it will give you the answer. For the JEE purpose, let us see. I will discuss all this crude approach and sophisticated approach. With very crude approach, we can approximate this V is approximately equal to RT by P. Do you agree? Please give affirmative. Do you agree? So Z can be written as Z is equals to 1 plus P by RT into B minus A by RT plus higher order terms. And higher order terms means what? If we wish, then we can also expand Z in terms of pressure, and we write it Z is equals to 1 plus, say, A dash P, the second virial coefficient, the B dash P square, and so on and so forth. We can also express van der Waals equation in this form. Okay, I don't know whether we have studied or not. That is why I need interaction. That if you say that no, if you don't interact in physical chemistry, the method could be very lengthy. Because similarly, if you don't, if you see the solutions in physical chemistry, they are very lengthy solutions. But if you understand them, then that could be a single liners. Okay, so please interact in between that. Do you agree? What is this? Because it can go to any extent. This we can spend whole time just describing this, but you understand, then it's all right. So the first and second, both are the valid options, but I will choose this for ITJ purpose. For JEE purpose, I think that is more than sufficient, but I will also discuss the next more elaborate approach. Taking this as a very crude example, can I move ahead? So Z is equals to 1 plus P by RT into B minus A by RT plus higher order term I have ignored. In that case, what we get, dz by dP is equals to what? dz by dP is equals to 1 upon RT B minus A by RT and plus some higher order terms. So that is the slope. All right, Ved. At least Ved will interact. I think you all are, very interactive, very good students. I know that the toppers, but toppers always they try to speak less. But I need somebody, anyone who should assist me. To give affirmative, even when you teach a story, you need somebody who affirm. Anyway, so the slope is equals to this. Now this we would like to find that the slope is going to vary with temperature. So at what temperature this slope is going to be maximum? So what we need to do, we need to differentiate it. That means del upon del t dz by dp. We need to find this. So if we need to find this, we are going to differentiate this dz upon dp with respect to t and set it equal to 0. Do it. So what you will get, let us suppose that slope is s is equals to 1 upon rt and b minus a by rt. So if you differentiate it, then d set ds by dt is equals to what it is. That is b upon rt square with a negative sign plus a upon rt cube and sorry, this is 2a upon rt cube and set it equal to 0. So this is going to give you b upon rt square is equals to 2a upon rt cube. So rt square, that is you getting t. So t is equals to 2a upon b. Okay. So that is the t which is coming. So I think that I have also done a mistake here. I have taken here, but it's not possible.
Sir, a by r square, 2a by r square t cube, sir.
Oh, yes. Sorry, you saved me. I was thinking that where r is gone, it was dimensionally not matching. Thank you very much. Good. So this t is equals to a upon rb. I was taken aback. I thought that maybe I've done some mistake in this, but no. Okay. So T is equals to 2 upon RB. Do you agree? So that is the temperature at which this is going to take a maximum value. This slope is going to take a maximum value. So if you put this value into this one, this expression slope was equal to z is equals to 1 plus P by RT and B minus A by RT plus P square upon P square into say some higher ordered things. Okay. P square, let's call this B dash, something like this. So you will ignore the higher order terms. So if you put this temperature precisely into this expression, you can also get that expression of Z at that temperature, and then you can find that slope. And what will be that slope value? That's also very interesting. The value of the slope will be, if you put this into this one, so that slope is equals to 1 upon R. Let's put T. T was equal to how much? 2A RB. And this is B minus A by R. 2A upon RB. This R is cancel, A is cancel, A is cancel. And this is B by 2 and B. And this is R is cancel. And this is B by 2A. B by 2A. And that is equal to B by 2. So this is coming out to be B square by 4A. If I have not done any mistake, okay. So that is going to be the slope. So this question has given you this interesting fact that the slope goes on increasing, and at one particular point that will reach a maximum value according to van der Waals equation. That is it. Taking the approximations that all other virial coefficients can be ignored. Now, Ved Prakash, can you get the answer?
Yes, sir.
Okay, what was the mistake? Can you tell me also?
I didn't use this form. I directly substituted from P plus A square by V square, that form.
You have directly done maybe very interesting thing. Please tell me what you have done.
P in that I ignored B value. V minus, as pressure is very low, volume will be very high. So V minus B approximately V.
Okay. You started from here. P plus A by V square. And V is equals to what? You started from here?
Yes, sir.
Okay, I got it. But then you can see that from this approach, we are not getting the answer. No? So I could not
Yes, sir.
explain it right now. Done. So that was a very crude approach. So can we discuss it any further that what will be the perfect approach? We'll get the same answer from the perfect approach. Just for this sake that to understand up to what extent this real gases can go. Okay. So there are certain, since I'm discussing this problem, the purpose is not to discuss this problem. Purpose is to just have an overview of the real gases. What real gases is, what kind of questions ITJ can ask, why they ask this question. So there are many parts to this question. Are you not interested in finding this very interesting thing? There are many questions in the real gases which we should ask. It's a very interesting topic. Are we not interested in this, that this graph is going down, and then at this point, this dz by dp is becoming what? Zero? So are we not interested in this, why that has decreased up to this point? And from this point, the slope is once again increasing. So there must be something that this slope z versus p graph must have something which first make it go dip, which first make it go down, and then make it go up. Why it first go down and then it started going up? What exactly is the thing? So I want that clarity. We want that clarity before this real gases is there. Their van der Waal equation has, we have lot of interest in van der Waal gas. Lot of interest. You know, there are van der Waal gas equation, there is Berthollet gas equation, there is Dietrich gas equation. There is a lot of other gas equations are there, equation of state. But in ITJ syllabus, they have taken only van der Waal. Why? Because this is the oldest one, very classical one, though it is not perfect. So at least we must know everything about the van der Waal. Why the graph is going down and up. Anyone who can answer me? And you want to go ahead with this discussion. So this is Z versus P graph. And we need exactly the precise expression of Z versus P according to van der Waal. Do you agree?
Yes, sir.
So how to go about doing it? You can do it. I think please don't pressurize me so that I should give you. You say that, sir, you are teaching such hi-fi things. You can do on your own. So I give you idea. Try it here. I give you an idea how you can do it. See, you try this idea. We know that PV upon RT, which is Z, is equals to 1 plus, let's call it A by V plus B by V square plus dash 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 dash. That is called virial equation in terms of volume. And we can also write Z is equals to 1 plus A dash P plus B dash P square plus C dash P cube, so on. So not many higher order terms, but at least up to this point we can go. And can we get the value of A dash and B dash in terms of A and B? So that will be very interesting thing. So I have given you a hint. You can do it. That get the value of A dash and B dash in terms of what? This one. How to approach it? So you see that the very first equation There are two approaches. I'll tell you one. Your approach should be like this. Like you see the first equation, see it carefully. We have to focus on this. We need to get this one because this is most important. Why this is most important? Because we always plot a graph of Z versus P. That is very important graph. We always talk about this. So what happens with the Z versus P graph? So every student, JEE has asked in last previous 40 years, they've asked only question on Z versus P. They have lot of interest in what? The compressibility factor. So why not they can give a twist to it? So national level examination, and maybe the generations are changing. So they give a slight little twist into this one, breaking into this one. They have not done it so far, but now the problems become so boring, always predictable. They're asking only the volume, they are giving pressure, and they're even not asking volume. They are what giving the volume and asking pressure. They are asking that this is the B value, what could be the probable, what is the probable molecular diameter? These kind of questions they've asked. What about this? That where this slope is going to be zero, why this slope is zero, what factors are there? Okay. So in view, this is advisable that at least a slight bit of you explore it. Let's do it now. So how you can do it? I give you one opening statement here. Can we write it that P is equals to RT by V and plus A by V plus P by V square plus so on. Sorry, P is equals to RT by V. That means I have to multiply it by RT by V. A RT by V square V RT by V cube and so on and so forth. We can think about it that we can write this is the expression of P here. And then if we substitute this into this one, and then if we substitute this in this equation, then Z will become Z is equals to 1 plus A dash. And if we substitute RT by V plus ART by V square plus B dash. Next term is B dash because we have to take only two terms. We will take maximum two terms. B dash and P square. That means RT by V plus ART by V square plus all the terms square of this. It looks very horrible, but believe me, if you start ignoring it, it's going to be simple. So what you do, you just Z is equals to 1 plus, pick only those terms which involve 1 by V plus something, 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 plus involve only 1 by V square and something, something, something. And whatever something, something, something is there, just compare and just equate it to what? Let us call this something, something, something is equals to what I should call it, U. Let's call this, no, not U will be confusing. Let us call this capital X and let us call this capital Y. So can we say that capital X is equals to B minus A by RT, and this capital Y similarly will be equal to, according to van der Waals equation, B square. So by comparing this, we can quickly get the values of this one. What? The first, the second, and the third virial coefficients. I hope I'm not boring you. And if any one of you are really having a copy and pen, you can always go about doing it. And you can tell me the value of A dash and B dash if I can give you 2 minutes time. It's a good idea. Should I give you 2 minutes time and you do it on your own here?
Yes.
Or you will try? You'll do? Okay, try that. Everyone, please try. I think you are all Sachin Tendulkars and Virat Kohlis, but I am a coach. I expect that you are faster than me. So if I start doing it, you should do it at least half the time what I take.
Sir, A dash is B by RT minus A by R square T square.
A dash is A by
B by RT.
B by RT and
Minus A by R square T square.
so you are saying that this is 1 by RT. Absolutely right. Very good. So I hope by very little thing you will also get this. You'll also get this B dash.
1 by R square T square into B square minus capital AB plus A capital A by RT.
B square minus
Capital AB.
capital AB upon capital AB.
Yes, sir. The small b one, the B small one.
B is a small one. Upon RT.
No, just that much.
Just
Plus
this. Plus
A capital A by RT.
so now you know already the capital A. If you substitute this value of capital A, you will also get, and this is B dash is equals to 1 upon RT square. You do it and you find it, probably that comes out to be 2AB upon RT minus B square upon RT square. Because you have to substitute this value of A also, na? And you've already calculated A
Yes, sir. We get
on RT and B minus A by RT. Fantastic. Very good. Okay. So see, these two terms are there. And now you understand how to approach this problem. You take only one term. So that comes out to be Z is equals to 1 plus 1 upon P upon RT. See, if I substitute this, B minus A by RT, and then plus P square upon RT whole square and 2AB upon RT minus B square upon RT whole square plus higher order terms. So in this way, we can, if you can take two terms at least, we easily get dz by dp. And once you get the expression of dz by dp, now this is coming out to be this is 1 upon RT, B minus A by RT, and plus 2P upon RT whole square and 2AB upon RT minus B square upon RT whole square. Now you have a fantastic equation. You can see this dz by dp is depending on P, and you can precisely get, if you differentiate it with respect to P, to at what pressure it is going to be maximum or minimum. So at least we have explored up to this point. That expression is going to give you something. So that is our maximum point, according to me. So for next 5-6 years, till JEE has asked some questions like this, I think that is the level which we would like to keep. And we have clarity with answer with clarity. What is Z by P, how it varies, where it goes down, why it goes down. And if somebody asks you why it is getting down, then you will find very interesting answer. Z is function of, P. So there are some P terms and there are some P square terms. If you find it carefully, you will find the coefficient of this P term is negative, and you will find coefficient of this term has to be positive. So when P is increasing, this negative term is increasing. That is making this dz by dp first dip. Why? Because it increasing P, this negative term is making Z lesser and lesser. But this positive term, is having less weightage. So when P is increasing, this term will become prominent only at very high pressure. So as you keep increasing the pressure, then role of this becomes very, very important, and that takes the graph above. तो ये ग्राफ को ऊपर लेके जाता है. That is the precise answer we would like to have in physical chemistry conceptual physical chemistry. For this, we need to define things properly. So that is from my side is the level. It should be the level. I will also check few more approaches before I move ahead, because since I'm talking about the real gases, which is a very interesting topic, I tell you, only few things I would like to indicate. Let's answer me this question as well. Point blank, please be interactive, then only we are going to learn. You know that there is a graph which was called liquefaction graph. I will ask a point blank question. Was van der Waal able to explain this graph?
Except the middle part, the others were explained by van der Waal.
Very good, Avinash. Fantastic. I like this. Except this middle part. Middle part was not explained. So tell me, what is so special about this middle part?
Even
What's so
this
special?
was explained up to a certain extent. Miss.
Yes, this was
We
explained.
get three values of V.
Very
real
nice. Very nice. Then we know that this van der Waal equation is V cube plus, I think that V cube minus, in fact, V square B plus A by RT, if I remember, because, you know, my memory is not that sharp. And what other terms are there? Anyway, some terms are there. Is equals to 0. It's a cubic equation. Idea is this, that van der Waal equation is a cubic equation. So actually, van der Waal has done what? He has shown a graph like this. So can we really say it explained everything? No. It could not explain this. This portion was not explained. This portion was not explained. This portion was not explained. Only this portion was explained. And only this portion was explained. And if you drop a perpendicular here, you drop a perpendicular here, you drop a perpendicular here, there is a volume. This volume is, let's call it VA. Let's call this volume VB. Let's call this volume VC. Or not VC. So there will be confusion of this VC will be what, you know, not XBY. We should write it what I should write. 1, 2, 3. 1, 2, 3. What is V1? Anyone quickly?
Volume of gas, pure gas.
Volume of gas. Fantastic. And what is V3? Volume of fluid. Most interesting point. At the same time, he has wrote an equation which is explaining fluid behavior as well as gas. That is why we have a lot of interest in van der Waal. See, a cubic equation which is giving me the volume of a liquid. That is the fantastic thing. And and what is this pressure? Anyone can tell me? What is this pressure? Very important pressure.
Vapor pressure.
Fantastic, Avinash. Very good. How do you know that this is vapor pressure?
In a closed container, liquid and water will be at, liquid and gas will be at equilibrium only at vapor pressure.
Fantastic. So this is vapor pressure. Very good. This is vapor pressure. So if this is vapor pressure, you want to say that gas was there. You started applying pressure here. P increased, and as soon as it reaches the value of vapor pressure at a given T, what happened? Bang. All of a sudden, this piston collapsed. Since you're interacting, I'm very encouraged. Why it collapsed? All of a sudden, the volume was changing from V1 to V3.
Liquefaction.
Because of liquefaction. And we know that liquefaction leads to a very, sharp decrease in volume. Very good. So what do you think, the process is reversible or irreversible?
Reversibles.
Reversible. Ved, it seems to be a reversible process. What is the criteria of reversible process? It should happen very slowly in infinite steps. But here this process is taking place very abruptly. How can you call it reversible? Do you have control over this process? Anyway, I have raised these questions. So do you agree that you're right? I'm not demoralizing you. You know very well. You know very well. But I only want to give you some additional point. Yeah, of course, you can answer is you can call it reversible or irreversible. And now anyone can tell me why I can call it reversible or irreversible doesn't going to make any difference here.
Pressure is defined at every point and it's constant, so
Very nice and very clever answer. Yes, you're right. So very nice and very clever answer. Good. So of course, pressure is defined and a reversible process is that process where every parameter is nearly defined. Nearly defined. Okay. So pressure, volume, and temperature, if they're nearly defined, we call this reversible process. So I really want to know this thing that if this is reversible process, then you just coming straight to the point. Maxwell has another scientist, Maxwell, same Maxwell you know about, he's given electromagnetic theory. He has given an idea that area of this portion will always be equal to area of this portion. That is called Maxwell's construction. And so with the help of Maxwell, van der Waals equation is able to describe even this flat part. Okay. So that is Maxwell's construction. Are you aware of this? Avinash, are you aware?
No, sir.
Okay. So be aware. So tell me, what struck to this Maxwell that he said that the area should be equal? Since this is such a thing, van der Waals, such a old equation, I think that to banta hai. Anyone can tell me why this Maxwell construction area should be equal to this one? Any guess? Wild guesses. Of course, I am talking about now you're getting into the IT. Not every question you will be knowing, you know. Wild guesses are very important. Like wild guesses, Ved Prakash has given, of course, that is precisely right. That though it seems that the pressure is collapsing, though it seems the process is very fast, still it is reversible because pressure was defined every time. Okay, it's very difficult to comprehend. Don't get demoralized. If you don't know it, you could not answer it because Maxwell was definitely a very intelligent brain and he has given this construction. So interesting point about this is that if you increase the temperature, you know, what is going to happen? This loop is going to be somewhat more like this. That means these 3 points are getting what? Closer and closer together. And you very well know that at certain point, this loop altogether vanishes and this point is known as critical point. So this is the temperature at which this loop will totally disappear. That means gas will convert into liquid and you will not even know it. So nicely the gas will convert into liquid. That is why van der Waals equation, if anybody is asking you the MCQ, that van der Waals equation is also an equation for a fluid, your answer will be yes. Because after above the critical temperature, you can say, and at the critical temperature, at least it has explained the behavior of fluid. And that is why you also study law of corresponding state. Done. So only last thing I'm going to tell you a hint about it. Can you justify this? Since you know a lot about it, can you justify this behavior? Can you justify this behavior? Maxwell's construction, that this area will always be equal to this area. That's a fantastic, very interesting point he made. Maxwell's construction, any shortcut, anything. I'm waiting for 1 minute time. Apply your mind. Hint I will give you. Use thermodynamics. Because Maxwell, Boltzmann, they're all champion of thermodynamics. Use thermodynamics.
Net work done is 0, so both should be equal.
Yes, that tukka is very good, but show me how net work done is 0.
P delta V comes out to be 0.
Okay, since you have done a very wild guessing, so I love this. So I can go, I'm going to give you the answer. Very good. And that should be the spirit. See this? You take this process as to be like this. Take it like this. And take it like this. Go from A to B, B to C, C to once again B, and B to A. What is this process? A, B, C, B, A. What is this process? Cyclic process. What else you can say about this? That is a reversible cycle. Because Ved Prakash has also given me a clue. The process is reversible. Why it is reversible? He told me that pressure is precisely defined. So if somebody is there who want to challenge me, no sir, this is not reversible. So I'm going to do what, I'm going to reverse this process. I will take it from C to B and B to A, then A to B, and then B to C. One step is this linear process you can see is a real process, and this looped process is a hypothetical process. Why hypothetical? Because it is the prediction of the van der Waals equation. And one more thing I'm going to write here, this is isothermal process. So it is cyclic process, it is reversible process, it is isothermal process. So in isothermal process, everyone know that dq reversible by t integral is equals to what? 0. Do you agree?
Yes, sir.
So if this is 0, then 1 by t, and this dq reversible also 0. Do you agree?
Yes, sir.
And which means what? Q reversible is equals to 0. So if Q reversible for a cyclic process is 0, which means W net is also 0. And if W net is also 0, can you see that these two processes, I need not explain it, that भैया समझ में आ गया? You understand what I want to say?
Yes.
Please give me affirmative. I should move ahead.
Sum is 0, not necessarily equal.
Now, sum is 0 with. So you so nicely said this. Look at it very carefully. How can the sum be 0? This is going like this. What is this cycle? This cycle is anti-clockwise. This cycle is what? Clockwise. Clockwise, work magnitude will be
Negative.
negative. And anti-clockwise work negative will be positive. So 0 means what? Negative should equal to positive.
Yes, sir.
Clear?
Yes, sir.
So what do you think? Was what that beyond? Now, can we tell that van der Waals equation was extremely successful, though van der Waals idea was lacking? Maxwell, thanks Maxwell, he has given a great idea. And in this manner, they've explained the whole graph.
Sir, here between A and C, 2 reversible paths are possible.
Yes. What is the problem? And if you have any objection, if you are going to tell me, sir, this is a very fast process, that is not a reversible process, then what I'm going to do, anyone?
What?
If-
Oh, you're shouting.
What happened? What happened, beta? Very shocking. Okay. See,
Try to speak వచ్చిందా participants వచ్చిందా
anyone want any explanation over here? So I tell you another very interesting point, that we could have done this like this. Take liquid and now slowly give it what? Heat. This liquid, you very well know, will reversibly change into its vapors. Take it here. So in this graph, if you are taking it from here to here, it seems very violent. Okay. So in this loop, you are going from here to here. It seems to be very violent. And then the loop was there. You could have come back like this, this, and this. Okay. This process seems to be very violent. Just make a reverse process. So reverse process is a very nice process. Take it slowly. Convert liquid into vapor and then take it back. See, this process is hypothetical. A, B, C, D dash, B, E dash. So I want to say A to C you can do. Practically you can do. C to D dash is a hypothetical process. Hypothetical isothermal process. Then from D dash to E dash, once again it is a hypothetical isothermal process. From E dash to A, it's a hypothetical isothermal process. What is the problem? Any challenge I would like to see?
A to C, can we have two isothermal different lines?
No, we could not have, because at the vapor pressure, if you slowly give heat to a gas, to liquid, it will slowly getting converted into vapor. What is the problem? That you always do. Isn't it?
Is A to C isothermal or not, sir?
I said isothermal. A to C is this process, bhai. At vapor pressure. This is vapor pressure means what? This is the boiling point of the liquid, beta.
Yes, sir.
This is the boiling point of the liquid related to the thermodynamic concept, na? A to C we are going, what we are doing? What heat we are gaining? Latent heat of vaporization. So during that time, do you think the temperature changes? No, it never changes.
From A to C, can we go in two different processes and both are isothermal?
I don't know why you're confused about A to C. A to C, you keep on doing always. A to C is you take water. Okay. You take water liquid at 373 Kelvin. You know what is the vapor pressure here? What is vapor pressure here? Vapor pressure here is 1 atm. You set a pressure over 1 atm here and start giving heat. What will happen? You tell me. Slowly, this 1 mole of liquid will be converted into 1 mole of vapor. The piston will go up. In the process, it will absorb how much heat? QP will be delta H vaporization. It will absorb that heat. And do you agree that the whole process was isothermal?
Yes.
Yes. So what is the problem? So that's what we are doing here. That's what we are doing here. A to C, think about it. It is at the boiling point. The liquid is at its boiling point. And you set the pressure equal to what? Vapor pressure. So external pressure is equals to what? Vapor pressure. You set that. So this liquid will slowly liquid gasify. So why I have reversed this process to give you the feel? Because from C to A, the process is abrupt. But from A to C, the process is what? Gradual. So you don't have any confusion that yes, we can do it. So now we can truly call this, if you have any confusion, yeah, of course it is a reversible cycle. Since it is a reversible cycle, then this dq reversible by t will definitely be 0, because that is the second law. I hope you understand. I hope you understand.
Yes, sir.
No, I'm not forcing you. Please uncam, you understand?
Yes, sir.
Okay, if you have any doubt, you can ask me. So that is a beautiful point of the van der Waals equation. So in MCQs, if somebody is going to ask you, what do you think van der Waals equation was successful? Extremely successful. It explains critical phenomena. It explains 3 volume. It at least explained 2 volume. And with the help of Maxwell's construction, this seemingly impossible task of explaining liquefaction was beautifully explained. Beautifully explained. At least 2 volumes are beautifully explained. Now we don't have much time about this because this is very last time. We can also talk about this point. This is a very peculiar point, it seems, because here, when pressure is increasing, volume is increasing. So it is a kind of an impossible thing, but it is only a theoretical process. That is why I am calling this C D dash E dash root to be a theoretical root. And it also evokes a lot of interest. So I think that to understand why JEE always ask one question on real gas. Because in engineering, when you enter, you'll find that we have a lot of interest in real gas. Without real gas, the thermodynamics and real gas goes hand in hand. So I have given this few points, additional points about this. That completes the discussion. Okay, if anything else you want to ask me, any doubts are there, you can ask me. Theoretical doubt, even that is in the real gas, I'm there to answer it. Otherwise, I will move ahead.
Sir, how did Maxwell construction helped us here?
It helped us here because it justified now. With can a polynomial, mathematically speaking, polynomial equation can explain this behavior? No. First derivative is not differentiable. There is a discontinuity in the first derivative. Do you understand what I'm saying?
Yes, sir.
So can van der Waals equation explain this behavior? No. So without Maxwell's construction, you could not explain this. Van der Waals has explained it like this. But Maxwell's construction has made this flat. So you can think about it, it's a mathematical tool with the help of which we can precisely Maxwell's construction plus van der Waals equation has explained liquefaction, not per se. Because any cubic equation could not explain this behavior where there is a very sharp, point on a graph. That is the
Yes,
idea.
sir.
Understood? Yes.
Yes, sir.
Okay. So that was the first question. Second question was also related to this one. Equation of state of real gas by this. You want to avoid it, you can avoid it, but this is nothing but I have not taken any name. This is Berthollet equation. You can see here A is dependent on temperature. So what is so special about Berthollet? When van der Waals equation is not giving very fine experimental results, we tried to take this A to be temperature dependent. In fact, it is temperature dependent. But near critical temperatures, it gives fantastic answers. Van der Waals equation is very famous. It gives very nice answers, but is it true? No. Is it true? Precisely true? No. It is only an idea of van der Waals. It's only a guess of van der Waals that this pressure should be the real gas pressure, but it always not matches with the observed pressure. So explain the difference between the observed one and the van der Waals equation. They keep on doing something. The first step was taken by probably was this Mr. Berthollet, and he has given A. Here this A is not that van der Waals A. So for this problem, I specially calculated this A and put it here. Okay, so if you solve this problem, you can estimate the TC for a gas according to Berthollet equation. Nothing big deal about it. Okay, now when I'm talking about it seems to be very hi-fi, but it is not hi-fi at all. A is temperature dependent. What you will do? How to go about solving this problem? Equation of state of a real gas is given by this. Estimate the value of TC.
Equate 3 volumes. All volumes are equal. 3 roots of this
Very good.
equation equal.
But Ved, this is more important thing. Del P by del V at constant T is equals to 0 and del square P upon del V square at constant T is also equal to 0. This is more important because it's a cubic equation. So in cubic equation, there is a point of inflection. And the critical point comes at the point of inflection. Because if you take this approach, it will not work everywhere. Here it will also work. It will also work, but this is more important approach. Okay.
This means the same thing.
Yeah.
This is a result of equal roots.
Yeah, this is result of equal root, but sometimes you go with the Dietrich equation, which looks like P is equals to RT upon V minus B, e to the power minus A by V RT. There you will find very difficult. So get what that know, because now equal root, that equal root, when these kind of equations will come, it is very difficult to, go about doing it in a proper manner, equal root method. So there you have to switch to this method. So why not keep it in mind, this method as well?
Yes.
This is the best method. Both are same, but not one thing is not practically possible to apply everywhere. Got it clear? Yes.
Yes.
My advice is that always rely on this one. Equal root is also very nice, but rely on this one. So I think that from this discussion, it is clear that if you do this, you differentiate it and set up these two equations, you will get TC expression, and I don't remember it, but it comes out to be 8A upon 27 RB. Have you got this?
R square B.
Oh, yes, yes, yes. I'm not good at memories. I'm only good at fundas. So it will come like this. Is it R square B?
A square by RB, I guess.
A square by,
Yes, the same, this one. A by RB by R.
I have to derive it, and you can also derive it.
We can do dimensional analysis.
Yeah, dimensional analysis you can do. Yes. Okay. So this way you will get the answer, but approach should be del P by del V at constant T is equals to 0, and del square P upon del V square is equal to 0. What funda you got here? That A and B are strictly constant in ITJ, but practically speaking, if somebody is asking you, like giving you, toss ball and say that, what do you think, A and B will never vary? So, in higher physical chemistry, they always vary, and they have a very different significance. Also, one thing you learned, that this van der Waals A will be different from Dietrich's A's or Berthollet's A. So for that, Dietrich's Berthollet A, this is Berthollet equation. You believe me, I searched on internet everywhere. I could not get this A value. So I have to practically construct this value to get these things right. Okay. And I'm talking here about the oxygen gas. So you can also match the answer with the oxygen gas real critical temperature. It will match. Done? Understood, everyone? Should I move ahead? Yeah. Have you tried this question? This was also a very interesting question.
Sure, shouldn't the equation still be same, because volume change will be included in concentration?
No. So I have to discuss slightly about the theory of this. So JEE has never asked this question, though I have put few questions like this while I was teaching in Bansal classes. So way back, 10 years back, I put the few problems you would have solved. So reactor-based problem. In this problem, first basic question a student asks, what is a first order process? So anytime they are going to ask, that is going to be a surprise. First order process. So you will say that, sir, basically it is dC by dt. Wrong. dC by dt is equals to kc is wrong approach. Because in dC there are two terms. Concentration is equals to what? Amount upon volume. So if amount and volume both are varying, see what is going to happen. See, can I say that dC is A by V by dt? If I write it like this, then this will become 1 by V dA by dt plus A dV by dt. So basically we're saying that dc by dt is equals to kc. Okay. What about this? And what about this? So have you ever done it? No, you will contend, your contention will be, sir, volume is constant. If V is constant, then we are going to use this. All right, when V is constant, then they are same. But if V is a variable, then you could not say this. Then you could not say. Can you say that dC by dt is equals to Kc for a first order process? With Prakash, that's a very important thing. And through you, all the student who is looking at this lecture, is it correct? No, this is not correct. Why? Because rate of change of concentration means what? There are two parts into it. Volume is changing. Due to that also concentration is changing. Can you say that this is due to the first order process? No. Do you understand what I'm saying? Very difficult to get it. I do agree. Very difficult to get it. I do agree. So keep it in mind. The problem is based on this factor, that this will be totally challenged as soon as volume is variable. If volume is not variable, then your approach is all right. But if your volume is variable,
Sir,
then yes,
in that step, d of a by v of d by dt, you have just divided, but you just written the derivative wrong.
please uncam and tell me who is there.
Sir, there in the step 1 by v of dA by dt,
What wrong I have done? Tell me. A is the amount, V is the volume, and I'm differentiating it. So first I have differentiated. Suppose A is varying with time, and also V is varying with time. So this variation of A with time is due to the first order process. Since suppose A is getting changing into B. So inherently, this dA by dt is representing how this reaction wants to change. But this volume V is also a variable here.
yes, sir, understood, sir.
Understood? Everyone understood? I hope that you understand.
Sir, we are calling first order with respect to concentration or moles.
It is always with respect to mole. That is why I created this problem. Because concentration is what? Concentration is made of two parts. Concentration is made up of mole and volume. Do you understand? Suppose volume is changing by due to some other factor, external factors. So reaction want that to be happen. The first order is with respect to what? Amount, now.
Yes, sir.
The volume factor can be changed by anything. Clear?
Yes, sir.
Yes. So do you think that the whole kinetics, when we study, this is the most basic thing from where we start, and we are shaky about this? So anyone can sense, because engineering, chemical engineering is totally based on this variation of the volume. Okay. So I think examiner can any day give you the twist. That is why I created this problem. You understand this problem? As soon as you see this phrase in ITJ, be alert. Now what to do? What to do? In this situation, the rate expression, the correct rate expression will be like this. We'll always do T of dt, and we'll multiply C by V. C is the concentration. And that is equals to K times of C into V. So when you differentiate it, that is, you are going to get what? First, focus on this part. Okay. So on this part, you can see this is going to be dC by V. That means V times of dC by dt plus what? C times of dv by dt is equals to k times of C into V. So if you take it, dc by dt is equals to a dc by dt is equals to V, cancel it out, k times of C and minus C by V dv by dt. This is how concentration varies. This is how concentration is going to vary. Okay. So what is rate? I think are you still confused? Now you're going to be clear. What is rate? Rate is basically equal to 1 by V dA by dt, and that is equals to k times of A by V. All right. What I have done? At any given time t, how the amount is varying. Now focus on this one. At any given time t, how the amount is varying this. This is this. And at that time, this volume is also variable of t. I've taken this t here. And in fact, I should write not here. I should write it simply 1 by Vt here. So this is how you should approach the first order process. Tell me if you understand this.
Yes, sir.
Totally understand this, no doubts. So if this is a zero order process, how you are going to write it? 1 by Vt dA by dt is equals to k. So very interesting thing. If I create a zero order problem, that is going to give you problem. Because in zero order problem, if volume is varying, then you see what will be your approach. The dA by dt will be k times of Vt. So you must know this. So zero order will be a problem. Second order will be also a problem. You're lucky that I'm asking only which order? First order. Why? Because in first order, this is going to cancel.
Even rate law is defined this way.
Yeah, once again, please ask, repeat.
Even rate law is defined this way, 1 by V into dA by
Yes,
dt.
yes.
Okay.
Rate law is always defined. The most scientific way of defining the rate law is this. Okay.
Is
Just
the
yeah.
order is given to volume also or only to the moles, sir?
Once again, please repeat this question.
We give power order to only volume or to the moles both?
We give power to the moles. Suppose it is a second order. That will make it all more clear. If it is second order, 1 upon Vt dA by dt you will write will be equal to what? K times of A power say x and A power 1, and suppose some other thing is there, B power 1. Okay. So you'll write here V, you'll write here Vt. If you just put it here Vt and Vt, okay. So now you're going to do it. This Vt is not going to be entirely cancelled. So once again, this dA by dt, this order will involve what? The volume term. And that is why second order will be too complicated for you. That will have methods, some special methods. So why I should going to ask you complicated things? J is all about we can ask to the students with the definition. So purpose of this question to make this thing very clear in your mind. I hope you are getting it. I'm not confused. Everyone?
Yes, sir.
So we are lucky in the first order. So as soon as we see first order, what we will do? The V will cancel. We will simply write the rate law for A. That means amount. And then if we know how volume is varying, so we'll write the expression of Vt, and the final step, we will divide that Vt by this one, and we will get the answer. So that is how I have done it. Probably last class you see this, though it has some sophisticated methods, but this method will also do. See what we have done the last class. In this case, simply write initial moles of A and B was there. And this question is also special because, we have taken some limiting region concept into this one. So this is a one limit on which somebody can ask you question, which is askable question, which has a very neat and clean integral answers and all this. So I think that with this, and have you tried that? Any one of you tried and get the answer?
I got the constant value difference, sir. Means the equation was looking the same, but your answer contained 11. My answer is having 14.
Have you checked the answer?
My answer is different, sir.
See, this is the answer. So suppose volume is increasing. I try to understand it by the volume. See, if the volume is increasing, at any case, the term 14 upon 11 plus 3 e to the power minus twice kt is there. Check it out whether it's true or not. See, if t is tending towards 0 when you started, then this quantity is 14 by 14. Okay. So when t was starting, this a should be equal to a naught e to the power minus 2 kt. Why? Because that time volume was not variable. Because since volume is directly proportional to number of moles, check it like this. And when this t will tends to infinite value, what will happen? This is the natural variation. This is the natural variation a naught, initial concentration e to the power minus 2 kt. It is varying like this. But at t tends to infinity, what will happen? See, 14 upon 11, this is the factor. So the rate appears to be somewhat the concentration appears to be somewhat more. The variation of A, you see, this is 14 by 11, somewhat more than what you expect from simple variation. Does it make sense?
I mean, if we send e power minus 2 kt below, we get decreasing term.
I'll solve it and show you.
I mean, not in that equation, you said it is 14 by 11 factor.
Yeah.
But if we send e power minus 2 kt below, we get 14 by 11 e power 2 kt plus 3, which is decreasing with time, not increasing.
Let me check the question. So see what is happening. 2a plus b is giving you c plus d. So what do you think? Volume, as this reaction will progress, the volume will decrease or increase? Volume is going to decrease. So if volume is going to decrease, what will be the impact on the concentration of A? Final concentration of A. Whatever you are expecting, if the volume was not changing, whatever you are expecting, the concentration should be more than that. Why it should be more than that? Because volume is shrinking. If the volume is shrinking, then concentration should go up. Does it make sense?
Yes, sir.
As this reaction is progressing, the volume is getting less and less. So if the volume was not variable, then A should be equal to what? A naught e to the power minus 2 kt. But since the volume is shrinking, this should increase more rapidly. So that is what is this factor of 14 by 11 is going to do. Okay. So answer is perfectly all right. Answer is perfectly all right. Your approach, see it very carefully, do it now, and you will get the answer. Otherwise, I will share the solution because today I have consumed a lot of time. So I will share. If you have any problem, just ping it to me. I'll give you the detailed solution. Although I have given it here, shown you like this one, but I think it is not tangible. If you don't understand, I'll give you the solution. So the series of 3 questions are based on this, and still I have not made any problem on zero order. So my next project will be make a very nice question on zero order, which is going to challenge everything. But I waited for them. I am waiting for this that ITJ should ask first time. So I believe that you have also done all kind of routine problems in chemical kinetics. Everything you're clear about it. If you have any doubts, you can specifically ask me. That is why I ask you Give me the task. So what I want to study, I want to know something about zero order, something about first order, why first order is first order. Okay. What is steady state approximation? Why we do it? So I assume that you have done all these things practicing and you know very well about all these things with absolute clarity. So I'm creating the problem, keeping in only mind that I should not waste your time, giving only the special questions which I feel like they can give you surprise and be aware of them. Understood, Ved Prakash, Avinash, and everyone?
Yes, sir.
What this problem is all about, you understand? Yes. Have you
Can you
seen?
once
Yeah.
that 14 by 11 significance? Can you once tell again?
Once again, I tell you,
That significance part is.
significance is this, that when t will tends to infinity, this reaction is towards the completion. Towards the completion, the volume is contracting. So
How
if,
did we say this volume is contracting?
because 2a plus b is changing into c plus d, and the gaseous reaction is taking place in a constant pressure container. So when the mole will become lesser and lesser, then this piston will come down now. Understood?
Yes, sir.
So that is why the volume is contracting.
Yes.
Understood?
Yes, sir.
So how to solve this problem? Idea is clear. You will simply write it for the amount. You will write the rate law only for amount. Okay. And you have learned from this problem that perfect rate law is what? 1 by Vt into dA by dt is equals to 1 by V Ka raised to the power 1. This, and this is also variable. If it is not variable, balle balle. If it is not variable, if Vt is not a variable, then you can simply write dC by dt is equals to Kc. But if it is variable, strictly you have to use this. That is the idea. And write a separate expression for Vt.
The third line which you wrote from starting
This one,
in the answer which you presented. What you annotated in the starting, sir.
this one.
Yes, that 3 minus 2x is equal to.
Yeah, this 3 minus 2x is nothing but this is the amount at time t.
This we are able to write only for first order, sir.
Yes. This is what? This is AT. This is what? A naught. As simple as that.
Yes, sir.
Understood?
Yes, sir.
Yeah. So pray for this. Don't try to look in complicated angle in every problem. Take a long deep breath. You have done normal kinetics. You've done so many problems, I assume. Only thing I have added this one, that correct your basic definition. All right. So that you have more confidence that nobody is going to cheat you. Or, and why I have discussed this, because next year you will be in the engineering. Maybe some of you will be taking chemical engineering. There it will be order of day. So every day they'll talk about what is the real definition of rate law. So the real definition will be from the amount. So do you think that ITJ can ask sometime? They should ask sometimes, what is your gut feeling? So that should be your gut feeling. So these 3 questions dedicated to that. Be prepared for that. Now next is, this question is also very interesting question. Have you solved this problem? Anyone? Ved Prakash,
Didn't get.
you didn't get this?
Yes. I mean answer.
Oh, answer, beta, I have checked many times.
I
Like
mean how to approach. I didn't get.
approach is this, that This is a unit area. And we know that how many molecules are striking here at in this unit area. So you see that dN by dt is given as number of particles per unit volume into area into C average divided by 4. Temperature is given 300. So you have value of this. And the rate of evaporation per unit area is given in SI units. That means we know dN by dt 1 by A. That is given in SI units. So this is N and this is C average by 4. That you know. 300 Kelvin, you know. So what you get N? What is N? Number of particles per unit volume. Once you know this, we know that PV is equals to nRT and PV is equals to nKT. So that means P by KT is equals to N by V. And basically this N by V is this. So we have P by KT is equal to 1 by A dN by dt, which is given, already shown you, upon C average, which you have calculated upon 4. K is given, T is given, this is given, this is given, get the value of P.
Yes.
This is a unique way of finding vapor pressure of a liquid, and it is related to the effusion formula. So that is why in gaseous state we study this, and that is a very, very important expression from the gaseous state. I hope that you know the importance of this formula, because otherwise you could not understand the rate of effusion. Don't tell me you cannot have feeling of rate of effusion, and you cannot have the feeling of what? M average wala funda. That whatever gases are coming out, M average is there. Na? So every problem is chosen very carefully for you. Now you understand what I'm saying, Ved?
Yes, sir.
So try, and question has been created in such a manner. You see the values have been given. KB is equals to 8 upon. Likewise, they're not real values are chosen so that you get the perfect answer. Pi's you have to take 3. So it's a workable problem we have given to give you the idea of vapor pressure. How you can calculate vapor pressure just by knowing the rate of evaporation. Because if you know the rate of evaporation, you know dN by dt upon 1 by A. Suppose you have vessel and the liquid is totally disappeared. Liquid totally disappeared in 10 minutes. And you know the surface area. So you can practically calculate that from a unit surface area, how many molecules has run away. So you can calculate by this simple method, you can estimate the value of 1 by A dN by dt. Then just note down the temperature, use this formula, and you can calculate the vapor pressure of that liquid. Isn't it amazing? Why this problem is so funny problem? Fantastic problem it is. You understand what I said last line?
Yes, sir.
Take a cup of water, wait, take a stopwatch, and just wait in what time that water disappears. And then do some calculations to get the value of dN by dt 1 by A. As simple as that. And now if this formula is valid, you can get the vapor pressure. Get the vapor pressure by some other method, and you can verify this equation as well. That's how physical chemistry runs. But two independent methods, from thermodynamics we can get the vapor pressure. This is, you say, from kinetics we are going to get the vapor pressure. Then we are going to match these two data, and if they are matching, we'll say fantastic. our estimation is perfectly all right. That is what a scientific thing is all about. So this is give you the problem 6 number. Any problem you ask me, everything is I've chosen very carefully interesting problems. So you try this problem as well. Have you tried this 7th question?
I'm getting a different answer.
Okay, you are not wasted much time, na? Ved? So
Yes,
I
sir.
feel very guilty about that. Okay. So try this question. I give you a hint. And don't waste a lot of time. When you start cutting this like this, ultimately one stage will come, then you will see something like this.
Octahedral.
Yes. And precisely which point you will simply get through this situation. Common sense and symmetry will make you like connect this point to this point, 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 connect this point to this point. You're getting what I'm saying? So connect this point to this point. Very nice looking, and so that point should be like this. That is the shape you can see. And I'm so sorry, ये connection गलत हो गया. This is गलत हो गया. Connect this to this and connect this to this. Connect this to this as well. See, that kind of a shape is there. It is almost octahedral. The point is, the tip of the octahedral will be where? The point is, the tip of the octahedral will be where? There, there, like this. So if you remove octahedral in a cube, it is like this. First of all, that is the idea for the sure. Can you get this length? Yes. Can easily get this length. Can you get this edge length? Yes. All these edge lengths, you know. Now the point is, when you cut a octahedral, what is going to happen?
Cube.
It's a cube. Where? Where? That's the question. Exactly where? So if you are getting it a cube, from this you got a clue that if you're cutting it like this, this and this, you're cutting this, you're cutting this. See this triangle. The triangle, a triangular face will cut like this. A one stage will come, then it will look like this. Do you agree? After this, if you keep on cutting it, then it will look like this. Then it will become, leave this. If you keep on cutting like this, it will be dislocated, and finally it is going to be what? At the center. Okay. So the cube will be, the edge of the cube will be at the center. That is the idea. From this, you can get the answer now. So all I want to say is, in this, center of this, center of this, center of this, and center of this will be the edge of a cube. Now try, you will get the answer. How many faces are there? 8 faces are there. In every 8 faces, there's a triangle. Go to the central point of the triangle, centroid of the triangle. That will be the edge of a cube. Now you can easily find the coordinates of this. You can easily find the coordinates of this and this. Use coordinate geometry, use geometry, whatever you want. Take this octahedral on some very symmetrical plane. Should I suggest you or do it on your own now? Write the coordinates of this. Write the coordinates of this x, y, z. Write the coordinate of this x1, y1, z1. And then what will be this? x1 plus x2 plus x3 divided by 3, something like this. Write also the coordinate of this and find this length. Whatever way you wish, you will find the answer. Understood what I'm saying?
Yes, sir.
So have you done this?
Yeah.
Have you, what was your approach?
I thought that vertices will lie on the edge of this octahedron.
No. Edge of the octahedral.
The
No,
top
not-
of edge is that
no,
way.
no, no, no. No, it will not. Think about it. The maximum cube will be in this one. And when you get the answer, you will also find very nice answer. Volume of this cube is probably, when I calculated it, it comes out to be 1/3 of the original volume in which that octahedral was inscribed. Probably like that. Okay, so you try this, you will get the answer quickly.
Okay, sir.
Okay. Now I will discuss this ionic equilibrium problem in the next class. And don't try to spend a lot of time here. Only approach it, and otherwise wait for it. I'll give the solution. So should I give you the solution of the kinetics problem, or you will try and you will get the answer? I'm very sure you will get the answer.
We'll try.
Okay. Okay. So, bachon, let's meet in the next class then. Keep on doing, have positive energy, and you are doing very well. Fantastic.
Can
Bye-bye.
you also discuss concept of inversion temperature?
Yeah, I'll discuss in the next class. No
Okay.
problem. Done.
14.
Anything
Question,
else?
question
Yeah.
number 14. Can you explain the question, sir?
Okay, how many distinct quantum states are possible corresponding to a P2 configuration? So, according to the Pauli exclusion principle, if you take a P2 configuration, so this is a one state and this is another state. Why? +1, 0, -1, +half, -half. All these numbers are going to affect the energy in the magnetic field, because this +1 corresponds to what? Physical state, because this is spin state and this is orbital. So there is L is equals to 0, 1, and 2. Do you agree that relates to the, L is equals to what? This corresponding to L is equals to 1, p orbital. So if L is equals to 1, that means it is the orbital angular momentum is 1. So if the orbital angular momentum is 1, so there is some magnetic field associated with this orbital angular momentum, because if somebody is orienting like this, due to this motion, there is some magnetic energy, magnetic field. There is a angular momentum and there is opposing magnetic moment. Do you agree? This is called magnetic moment due to the orbital motion, and the electron is also spinning. So that is also giving rise to what? μs. Now they are going to interact. So if sometimes this μl has value +1 and μs has value -half, what do you think? The energy will interact and they will have a different energy? Of course, that's called spin orbital interaction. So that means that these two configurations have different energy. Even this and this is also different. Sorry. So how many quantum states are there? Should I discuss the answer?
I'll try from here, sir.
Yeah. Just let me just give you a hint. If there is only one single, how many distinct quantum states should be there?
6, sir.
6. So there are 2. Definitely, number of quantum states will increase. There are 6 distinct quantum states if one single p electrons are there. That is it. Okay. That was the idea of the problem. Done, everyone? So let us meet in the next class with some new ideas, and inversion temperature I'm going to discuss, and few more questions which are left here. In liquid solution and kinetics, I think we are almost done there. So I will have to just once again frame few more questions for the next class. If any specific topic you want to discuss, you can tell me, and I can discuss as well, the theory of that part as well. Anything with Prakash apart from this thing?
I'll think and say, sir.
I think what? Which one?
I will think and say, sir.
Okay. Take care, बच्चों. Bye bye.